Welcome to discussion 14. In today's discussion, we'll be focusing on section 3.4 on the chain rule. And in this video, we'll be doing some practice problems that involve powers and roots. So let's recall that the chain rule says the following. If we take the derivative of f of g of x, that's equal to, I take the derivative of the outside function, f, and then within that I keep plugging in the same inside function, g of x, but then I multiply that by the derivative of the inside function, g prime of x. So our memory trick for this is if I'm taking the derivative of f of, not just x, but f of some stuff, the chain rule says, well, take the derivative of the outside, you'll get f prime, and then of the stuff, f prime of the stuff, and then multiply that by the derivative of the stuff, the derivative of the inside. All right, so let's do some practice problems. So from worksheet 6, I want to look at parts 9, A, B, C, and D. Okay, so these 4 questions, and I want to first give you 8 minutes to try these. So pause the video in 4, 3, 2, 1. Pause it and try these for about 8 minutes. Alrighty, so hopefully you've done that. Hopefully paused it and tried them for about 8 minutes. Let's talk about them together. Okay, so looking at this function, I noticed that what we have is, instead of just having like x to the 4th, we have some stuff. We have some stuff to the 4th power. Okay, and this is going to involve the chain rule. This is going to involve the chain rule because it involves some inside function being plugged into some outside function. In this case, the stuff is what's getting plugged in. And it's getting plugged into like this 4th power function. Technically, the outside function is x to the 4th. But the 4th is kind of, the 4th power is representing, well, what is outside? All right, so if we use the chain rule, it says, okay, our derivative is going to be, first I take the derivative of the outside function. So I'm going to deal with this 4th power, and I do power rule. I bring that 4 down. And I'm going to subtract 1 from the power to get a 3. But the chain rule says when you do that, when you take the derivative of the outside function, f prime, keep plugging in the same inside thing, g of x, in. So don't plug in x, but plug in g of x, the inside function. And in this case, my inside function is 3x minus x to the 4th plus 1. And then we have what I call the chain rule step, where I have to multiply by the derivative of that inside thing. So the derivative of 3x minus x to the 4th plus 1. So we get f prime of x equals 4 times 3x minus x to the 4th plus 1 cubed times this derivative is going to be 3 minus 4x to the 3rd. And that is our answer. All right, so that was part A. Let's look at part B now. All right, so for part B, we have that same function as before, but it's being multiplied by 3x plus 1 squared. So for this, I have these 2 functions, this whole thing, and then multiplying this whole thing. So I am going to do product rule first. So we need product rule, at least initially. So doing that, we'll get f prime of x. Product rule says, take the first function, 3x minus x to the 4th plus 1 to the 4th, and multiply it by the derivative of the second. So multiply by the derivative of the second function, 3x plus 1 squared. And as we do more chain rule problems, eventually I will just start doing this derivative all in one step. But since it's our first discussion, we're practicing this, I'm going to show this step. All right, and then I do plus the second function, 3x plus 1 squared, and then times the derivative of the first, times the derivative of 3x minus x to the 4th plus 1 to the 4th power. All right, so we have these 2 derivatives to do, and both of them involve some stuff to a power, to a constant number power like we had in part A. And that requires the chain rule. So we already did this one in part A, that's the chain rule, and this one's also going to be chain rule. Okay, so if we do these remaining derivatives, we get f prime of x equals that 3x minus x to the 4th plus 1 to the 4th. And now for this derivative, I deal with the outside thing first. That's that power. So I bring the power down, and then I subtract 1 from the power to get a 1 up there. And when I do that, I keep the inside thing the same. I keep plugging in my g of x. This is 3x plus 1. And then we multiply this by the derivative of the inside, which is 3. Okay, so we have done chain rule on this term. Then we're going to get plus 3x plus 1 squared. And we've already seen how to do the derivative of this term, because that was the problem in part A. That's going to give us, let's see, the 4 comes down, and then times, we had, let me put a 3 there, and then I keep the same inside function, 3x minus x to the 4 plus 1, times the derivative of the inside thing, which remember was 3 minus 4x to the third. And that is our answer. Okay, maybe it looks a little bit nicer if I put a parentheses around this 2 to indicate it's multiplying everything here. Same thing around the 4 to indicate that it's multiplying these other terms. All right, let's do part C now. Actually, no, sorry, let me make one note before we move on to part C. So I want to make a note, and this is more just a general comment, so I'm going to write it quickly. And that is something that I mentioned earlier in words, but now I'm writing it down. As we get more comfortable with these chain rule problems, we can do this derivative all in one step. Even if within the problem I need a product rule and a quotient rule and need to combine some rules, we'll get better at doing it all in one step. All right, so let's practice that in part C. So we have this function, this cube root of this fraction. So we've seen that with the roots, we can rewrite them as powers. We get x minus 1 over x plus 1 to the 1/3 power. So what we have is some stuff to the 1/3 power. Okay, so this is definitely going to be chain rule, because I see an inside function. It's all that stuff, that fraction. And the outside function is technically x to the 1/3. That's what I'm plugging the stuff into. All right, so if we take the derivative, it says, well, deal with the outside thing, the power in this case first. So the power is going to come down, and I subtract 1 from the power, which will give me a negative 2/3. And when we do that, we keep the same inside thing. So the inside thing is x minus 1 over x plus 1. But we have to multiply this by the derivative of the inside. So for the derivative of the inside, we are going to need quotient rule. So in what I'm about to write, this will require the quotient rule for the derivative of this inside fraction. Okay, so if I do quotient rule, we get low d high. So low derivative of the top is 1, and then minus high. So high is x minus 1. D low, derivative of the bottom is 1. And then over low squared, over x plus 1 squared. Okay, so that is our derivative. And for practice, I am going to simplify this a little bit. Okay, so we have this 1/3 x minus 1 times x plus 1 to the negative 2/3. All right, and that's going to multiply this next fraction. Okay, so on the numerator, I have x plus 1 minus, and then in parentheses, x minus 1. If I distribute this negative sign, the x's will cancel, and I'll be left with 2. On the denominator, I will have x plus 1 squared. All right, and I'll box that. That is our answer. That is our derivative. All right, so one final example in this video. We have this function f of x, which equals 3 over 1 plus the quantity 2 minus x squared being cubed. Okay, let's do this in 2 ways. So method 1 is going to involve the fact that I see this fractional function, so I can think, okay, I can do quotient rule. Quotient rule. So if we do quotient rule, we'll get our derivative is, so I'll do low d high. Low is 1 plus the quantity 2 minus x squared being cubed. That's low. D high, so derivative of the top is 0, because the derivative of a constant is 0. And then minus high, which is 3, d low. So for the derivative of the bottom, derivative 1 is 0, because that's a constant. And then for this whole thing, 2 minus x squared being cubed, I need the chain rule. Okay, and first I deal with the outside thing, the power. That 3 is going to come down. And then I subtract 1 from the power to get a 2 there. I keep the inside function the same, the 2 minus x squared. And then we multiply that by the derivative of the inside function, which is negative 2x. All right, so I'm going to close that. So this was coming from the chain rule. The chain rule on the 2 minus x squared being cubed. All right, and then so that's low d high minus high d low all over the bottom squared, all over low squared. So 1 plus 2 minus x squared cubed. That's our low. And we got to square that. All right, so if the problem didn't tell me to simplify, it would be fine to leave our answer like this, and that's what I'm going to do. Although this definitely could be simplified a little bit. For example, 0 times something is just going to be 0, so that will go away entirely. Okay, so let's do this one other way. Method 2. So it's possible to do this without the quotient rule. If I bring the whole denominator up to the numerator, so if I rewrite it first, so I can rewrite my function f of x as 3 times, and then the whole denominator being raised to the negative 1 power when I bring it up. So that's 1 plus the quantity 2 minus x squared being cubed, that whole thing, to the negative 1 power. All right, and now when I take the derivative, well, this is chain rule. This is chain rule. So if we do this derivative, f prime of x, 3 is multiplying this function, and so if I have a constant multiplying my function and I take the derivative, I can just keep that constant out in front. So we'll have 3 times whatever the derivative of this function is. And for that function, I got to do chain rule. The outside thing is this negative 1 power that I got to deal with. So that negative 1 is going to come down. It's going to multiply the 3 to give me negative 3. I'm just going to write that from the get-go. And then I subtract 1 from the power to get a negative 2 in the exponent. Okay, and when I do, I keep the inside the same. 1 plus 2 minus x squared, that quantity, being cubed. And then we multiply this by the derivative of the inside, the derivative of all of this. So the derivative of 1 is 0. And then for the next term, we've already seen what that derivative is. It involves chain rule. And we get 3 times, subtract 1 from the power, and then 2 minus x squared stays inside. And then I multiply by the derivative of 2 minus x squared, which is negative 2x. So that's coming from chain rule. Yes, okay. And that is it. At this point, I've finished my chain rule. I had to do chain rule a couple of times. All right, and for practice, if I needed to simplify this, what would this be equal to? So this whole thing to the negative 2, I'm going to rewrite that and bring it to the denominator as a positive 2 power, and now I'll get 1 plus 2 minus x squared being, being cubed. And notice this is starting to look like what I got from method 1. And then if I multiply, actually if I look at the remaining terms that I have, it is exactly what I had from method 1. But for practice, let's multiply them. So let's see, negative 3 times negative 2x, that is going to give us positive 18x. And then I'll still have that 2 minus x squared being squared.